In this video, we're going to talk about enumerated types. We're going to talk about a special kind of enumerated type called a flags enum. We're going to talk about what kind of arithmetic you can do on enums, and also how you can create your own enumerated types. So let's just jump right into Visual Studio and take a look at an example. All right, so here I once again have a little console application that I'm just using to demonstrate some of the different kinds of features that enumerated types have. Now you remember from the previous course that an enumerated type is an integer that is referred to almost always by its name rather than by its integer value. So for example, we had a type datetime that gives you the ability to represent a date and time combination. And we have a property datetime now that tells us what time it is right now. And then I can say, well, what is the day of the week of that thing? And this thing here, day of week, is an enumerated type. You can see it says enum system.dayofweek specifies the day of the week. And if I actually debug into this code, right, then we can see that day of week is Monday in this case. It's day of week.monday. Now, why are these things called enumerated types? They're called enumerated types because there's a small, finite number of possible elements or choices that we can enumerate over. So, like the days of the week. There's only 7 of them. It's small, it's finite. Each one of those things has a name. So it makes sense to treat those things as an enumerated type. So for example, we could say that suppose the day of the week were Thursday, right? Then we could assign that value to this variable and then use it programmatically, rather than having to say, oh, well, I'm going to create a magical number, and I'm going to say that, well, let's see what it is, 4. I'm going to say that 4 is Thursday, and just throw out my program every time I mean Thursday, I'm going to use the number 4. No, that is a bad idea. It is a much better idea to use something that is descriptive and readable, and yet has all of the properties that you'd like a value that refers to one of a small number of possible values to have. Right? It's simple, it's easy, it's just an integer, right? But you want to talk about it by name, not by its value. So here is a common use of an enumerated type. We have this string that's got a bunch of sentence fragments in it. And I would like to split that string apart into an array where the array contains all of the words. So I'm going to get rid of the punctuation. So this method, split on string, takes as its first argument an array of characters. And these are the characters that are going to be used as the separators. So in this case, I've got the space character and the period character. And then the second argument is an enumerated type that is either remove empty entries or, well, let's use IntelliSense here. It says there's only 2 possibilities, none and remove empty entries. All right, and none says include array elements that contain an empty string, and remove empty entries says the return value does not include array elements that contain an empty string. So OK, so first of all, what is this for? Well, there are 3 separators in a row here. There's a period and 2 spaces. And so the question is, in the resulting array of words, should it be sentence, fragment, and then the empty string that is between this period and this space, and then the empty string that's between this period and this space, and then another? Moreover, there's a period here. Should it also include the empty string that is after that period? Now, you can imagine that there might be circumstances in which you would want those empty strings. There are circumstances in which you might not. We want to be able to say which one we want. The question is not, how does this method work? It seems like a perfectly useful method, but we're talking about enumerated types here. The question is, why did the designers of this method choose to have an enumerated type here rather than a Boolean? Because they could have just simply said, true or false, do you want to remove the empty entries? And the reason is twofold. Right? One is because this is way easier to read. Right? Imagine if this said sentences.split, and there were an array of characters. It's like, OK, you can read the code and think, oh, well, they must be separating on these bunch of characters. That makes sense. And then you see false. Well, what does that mean? You are immediately taken out of the code. You're no longer understanding what you're reading, and you would have to go to the documentation or to IntelliSense or something else to look up what does false mean. Does false mean remove the empty entries? Does it mean preserve the empty entries? Does it mean something else entirely? The other reason that we'll see in a minute is because the designers of this method were trying to think about the future and thinking they might need to add more options in the future, right? Like suppose they want to say, well, I want to be able to split this string and I want to do case-insensitive matchings versus case-sensitive matchings, right? So if I wanted to split this on the letter A, right, let's say, would I want to split on this A? Would I also want to split on this capital A? Well, maybe that's an option that you could pass in. That's not a feature that they added, but they were probably thinking, you know, we might want to add features like that in the future. So let's make this thing, rather than a Boolean, which can only take on 2 values, make it an enum, which can take on many values. All right. So I want to contrast 2 different kinds of enums. And again, I'm going to digress for a moment here and talk about how the operating system handles files. You know, you can have a program that opens a file, does some operations to that file, and then closes the file again. So when you're doing that, the method that opens the file takes some arguments that describe how you would like that to be handled. And there's in particular 2 things that are of interest to us today. One is called the file mode. And the file mode is essentially what's going to happen when we open this file. Are we going to truncate it? Are we going to append stuff to it? Are we going to erase it and replace it with a different file? Do we require that there be no file there and we're going to create a new file? What's going to happen? Right? How are we intending to treat this file when we open it? The other interesting fact that the operating system needs to know your intention about when you open a file is, suppose 2 programs try to open the same file at the same time. Suppose one of them says, I would like to read this file, and the other one says, I would also like to read this file. Is that OK? Suppose one of them says, I would like to read this file, and the other one says, well, I want to write this file while you're reading it. Is that OK? And so on. Suppose one program says, I intend to delete this file, and so on. So there's a bunch of different possibilities here, and you can see that they're kind of distinct. And so there's 2 different ways to describe them. There's a file mode enum, and there's a file share enum. Now, the file mode enum, I want to just use IntelliSense here and see what this can possibly be. There are 6 possibilities. They're append, create, create new, open, open or create, and truncate. Now, I don't want to go into what each one of these things means. The point here is that all of these are options that are distinct. It doesn't make any sense to combine them. Well, apparently somebody thought it made sense to combine open or create, but they did so by creating another option that was open or create. So there are 6 ways that you can open this file, right? And none of them can be combined with each other. Now, with the file share enum, by contrast, we also have 6 things. They are delete, inheritable, none, read, read-write, write. In this case, it also seems like, well, there are 6 things. One of them is none, which seems a little bit odd. One of them is, again, a combination of the other 2. The question is, does it make sense to combine, let's say, write and delete? I would like to open this file, and I would like to share it with anybody who wishes to write or delete this file. It seems like that is a sensible combination, and yet there is no read and delete, write and delete, the way there is a read and write. But still, it seems like these 2 things are different in some way. It seems like one of them is a collection of distinct values, whereas another one of them is a collection of options, in a sense. So the distinction that we're making here is that there are 2 kinds of enums, which I like to call regular enums and flags enums. And I want to talk a little bit about this jargon word flags. Boolean values are often called flags by analogy with a flag. If the Boolean is true, then the flag is raised. If the Boolean is false, then the flag is lowered. And you often hear these analogies being made when people are talking about Boolean values. They say the Boolean is up or down rather than true or false. Flags are often used in the context of, I've got a bunch of different flags that I would like to combine into one value. And this example with the file sharing mode is a good example of that, right? Where I might want to combine reading with writing or writing with deleting or whatever. All right, so how would we actually combine values in a flags enum? The way you do that is with this pipe operator, which is an operator that I don't think we saw in the previous course. It is closely related to the logical OR operator, which is two pipes. And we'll see why it's so closely related to that in a minute. But if we run this code to here, right, we combine these two things together. And then if I use IntelliSense and mouse over here, sure enough, it says that file share is read, and then the pipe, and then delete. So it seems like this thing no longer is just a collection of distinct values that we could enumerate over, the same way Monday, Tuesday, Wednesday, Thursday, Friday are distinct values we can enumerate over. It looks more like this is a collection of flags that are either up or down, right? So this is saying the read flag is up, the write flag is down, the delete flag is up, and so on. Well, what's really going on here? If we highlight the type and then hit F12, we actually, Visual Studio will display you information about this enumerated type. And something that you notice here is, let's ignore read, write for now. We have none, read, write, delete, and inheritable. And they are 0, 1, 2, 4, and 16. And the thing to notice about this is that these are all powers of 2. So imagine that you were writing this in binary. Right. Suppose we had the read flag, right? We wrote that thing out in binary. Well, it's 1. So in binary, that would be 0, 0, 0, 0, 0, 0, 1. We have the delete flag, which is 4. So that would be 0, 0, 0, 1, 0, 0. Now imagine that we treated the zeros as false and the ones as true. And then we did a logical OR operation. Remember in C#, that's the two pipes. We did a logical OR operation between them. What would we get? Well, 0 or 0 is 0. 0 or 0 is 0. 0 or 1 is 1. 0, 1 or 0 is 1. So we would get 5. Right? So this is how we have combined these numbers. Right? Remember, enums behind the scenes are just integers. And that's what we're doing here, is by combining these two flags together, we are saying, or their integer values together as though they were binary numbers, and take a look at the result that you get. Now, you might say, isn't this just addition? We could add 1 and 4 and get 5. Right? But that's actually not quite right, because you think that, well, suppose I have read, and I want to combine that with read. And that seems like maybe it's a nonsensical thing to do. But if I want, if I want this flag to be up, I should be allowed to combine it with itself. But I don't want to add it together, because read plus read would be equal to write. 1 plus 1 would be equal to 2, whereas read or read would be equal to read. And C#, in fact, does not allow you to use addition in this manner. If I try to say I want to add the read and delete values together, it will produce an error that says operator plus cannot be applied to operands of type file share and file share. You can only OR them together if you want to do this kind of combination. All right. So that's how you combine flags together. How do we take a value that has a file share in it and test whether a particular flag is set? Well, the wrong way to do it would be to just say, is this thing equal to fileshare.read? Because, well, let's just take a look at this in the debugger, and we can see why it's wrong. All right. So file share is equal to fileshare.read or delete. If I compare it to read, right, then this is false, because it's not equal to read. It's equal to read or delete. Instead, there is a special method called hasFlag, and sure enough, hasFlag says, yeah, this thing has the read flag. Now, this method, hasFlag, is a relatively recent addition to .NET. You will see, if you look at legacy code, you will see this very gross-looking expression. So let's unpack this a little bit here. What we're doing here is we are using the AND operator. And recall, this seems highly reminiscent of the double ampersand operator, that is the logical AND operator in C# that we saw in the previous course. And then we are comparing the result of this operation to fileshare.read. And this works. This guy is true. Why does this work? Well, again, let's take a look at a little Boolean truth table here. File share we know is 5. It's got the delete and read flags. Read is 1. And now we do a logical AND of these things together, treating the zeros as false and the ones as true. Well, this guy is going to be 0, 0, 0. This is going to be 0 because it's not the case that both of these are 1. This is going to be 0. But it is the case that both of these are 1, so that's going to be 1. The result is 1, and that is equal to read. Right? So this is how we test to see if a specific flag is there. All right. So I mentioned that you could not add two enums together. Funnily enough, you can subtract them. Right? So if I say, I would like to know what Friday minus Wednesday is, that's 2. And I guess that kind of makes sense, because there are 2 days between Friday and Wednesday. So if the subtraction of two enums produces an integer, then you would suspect that the addition of an integer to an enum should produce an enum. So for example, I could say, well, what's tomorrow? Right? Well, we already said that day of week is Thursday. Right? Remember, I wrote Thursday into this variable at the beginning of the program. I could add 1 to it, and sure enough, tomorrow is Friday if today is Thursday. But you got to be careful. Suppose I have Saturday, and I add 1 to it, and I'm going to say, well, that result is Sunday. Right? And now if I point at this thing, it says 7. It says 7. It does not say Sunday. Why does it say 7? Well, if I take a look at the day of week enum, we can see that Sunday is 0, Monday is 1, and so on. Saturday is 6. We asked C# to add 1 to Saturday, and we got 7. We did not get 0. C# has no idea that you would like this to wrap back around to 0. Right? It just treats it as integers. There is nothing whatsoever that stops you from getting invalid enum values out of operations on enums. So you've got to be super, super careful. They are, in some sense, not as type safe as you would like them to be. Now, we've already talked about how addition on flags enums makes no sense. You always want to do OR and operations. Subtraction also makes no sense on flags enums, but it's still legal. You can do it, and if you do it, then it's almost certainly a mistake. So my advice is, first of all, avoid flags enums if you can, because they're confusing. They're really kind of old school. But if you are going to do operations on flags enums, always do bitwise operations on flags. Always do addition and subtraction very carefully on normal enums. So I want to talk a bit about creating your own enums. The syntax for that is written like this. We just have the keyword enum and then the name that we want. And then inside curly braces, a list of members and the values that we want. The value that you give it must be a constant integer expression. So let's take a look at an example. So now I am outside the program class. Normally, I would put an enum definition in its own file entirely, but I'm not going to do that this time. I'll do that in an upcoming video, and you can see how that works. It's illegal to create an enum inside a class. Remember, we have this class program, right, that all of our code is in. We could create this enum in that class, but we don't have to, and it's a little bit rare to do so. So anyway, we have the keyword enum, then we have the name. We'll call this enum size, and then I'll give it 5 t-shirt sizes, extra small through extra large. If I point at these, right, then IntelliSense says, well, this one's 0, this one's 1, this one's 2, this one's 3, this one's 4. So C# has automatically assigned these values for you, which is nice. Now, you can choose to assign values if you wish. So for example, here I have an enum which is tennis scores. Right? The tennis scores are love, 15, 30, 40, and game. And they also have numerical values associated with them, which are 0, 15, 30, 40, and 60. And you can then use these values as you see fit. Now, like I said a few minutes ago, I'm not a super big fan of flags, enums in modern code. They are really kind of there for interoperability with existing code. They can be confusing. But if you do want to create a flags enum, you do it like this. So the first thing we do is we create the enum, and then before it, we put in square brackets the word flags. This is called an attribute. This syntax of putting an interesting fact about a type or a member or the return type of a method and so on. We put interesting facts about these things in the program by surrounding a word that refers to an attribute type, in this case the flags attribute, in square brackets. And that syntax tells the compiler when it emits the code for that type, there's something special about this type that somebody might want to know about. The attribute syntax can be quite complicated. In this course, we are only going to look at the very simplest attributes. And we're not going to talk about how to create your own attributes. So all of the attributes that we look at will just be a word inside square brackets, just like that. All right, returning to our example in Visual Studio, the other key thing to keep in mind when you're writing a flags enum is that all of the values should be powers of 2, so that they can be combined easily using this binary arithmetic. Also, there should always be one of the values called none, and it should be equal to 0, because that way you have a nice, clean way to say, I want none of these flags. I want them all to be false. Now, if you've been paying attention, you might wonder, why is it that back up here, when we had the file share enum, why is it that Visual Studio said that read-write was 3? Right? Well, that's, of course, because read and write, when combined together using binary arithmetic, give you 3. It's very common for people to combine read with write. And so whoever designed this enum, just as a convenience for you, said, I'm going to not make you write read, pipe, write. I'm going to just allow you to write file share.readWrite. So that's why that's there. All of these others in here are powers of 2. All right, summing up, enums are just fancy integers. They are integers that have names. You can combine them together using the OR operator, the pipe operator, if they are flags. And you can use the hasFlag method to test if a particular flag is on or off. You can use integer addition and subtraction on non-flags enums, but you've got to be super careful because nothing prevents an invalid enum value. And you can very easily create your own enums. The syntax is totally straightforward. Just enum, the name, and then a list of values inside curly braces.